Let's get started.
All right, great. All right, well, good afternoon, everyone. My name is Sue Juder. I'm the marketing specialist here at Business Machine Technologies. I wanted to welcome all of you to the second episode in the final session of our Remote Works webinar series. Today, we're going to be discussing server-based computing. Before we begin, just a couple quick things about our Remote Works webinar series. Every Tuesday at 12:30, we're going to be hosting a short webinar on a different topic. We will highlight capabilities within that topic that will assist with your work from home efforts. The sessions are tied to a different series or theme. The first three revolved around communication, collaboration. The second three were tied to security. And finally, we will close with strategy. When you sign up for one session within the series, you're automatically enrolled for those in the remainder of the series. So those who are registered for today's events are automatically enrolled for next week's episode, which is downsizing of office space and moving servers to the cloud. So we look forward to seeing you next Tuesday for that session. And again, the best news for this, all these sessions are free and they're all designed to assist with your work from home efforts. So we encourage you to register and join as many as possible. All right, so with that, we are going to start today's presentation on server-based computing, and I'm going to turn the deck over to my colleague, Stu.
Thanks, Sue. Today we're going to explore the benefits of server-based computing. For many organizations, this is the first step required to move their locally hosted applications up to the cloud. This can almost be considered a prerequisite for next week's webinar, so let's jump right in. Server-based computing refers to a technology where applications are implemented, supported, and operated on the server rather than the client. They offer some key advantages. Mobility. You can work from anywhere, office, home, remote, and on any client. PC, Mac, tablet, even your phone. Next is security. Since all the data stays on servers and never makes it to a PC, there is much less risk to that data. Savings. You install an application or update once, and it is immediately available to all staff. The end user's computers can be converted into terminals and may be replaced with simpler, more affordable devices, which are known as thin clients. This is why server-based computing is sometimes referred to as thin client computing. As we mentioned, applications are installed on the server and they're published for clients. Since the most powerful version of this is a published desktop, where you sign into the server and you have access to all the applications installed on the server. These servers are usually called remote desktop servers. What you see is a desktop, just like a desktop that would run on a PC, with icons on it, a start menu, taskbar. With server-based computing, administrators find it easier to deploy, monitor, manage, and support different applications, since these are all held on a central machine or server and are managed from one point. Since a remote desktop server has to support many users, they are loaded up with RAM, processing power, and fast storage. When you consider the average $900 desktop has 4 processor cores, 8 gigs of RAM, and a fast SSD drive, a $10,000 investment in server hardware will support these same 45 users and does the same work as $40,000 in PC equipment. For a true cost comparison, we must also add in the licensing for each remote desktop client. A remote desktop user or device client access license costs $130. You can license whatever you have fewer of. If you have fewer users, license those. Fewer devices, you can use that count. We typically only see fewer users in manufacturing, where there is a PC at each machine on the floor, and a staff of 10 can run the floor of 20 machines. Fewer devices is more common, where you have a business with shift work and 3 people may use the same device over the course of a week. And we also need to look at what devices are used to connect to the remote desktop server. So if we start at our per user cost for the server hardware and client access licensing, that works out to be about $356 per user. And let's look at the cost of some of the devices. Because all applications are installed on that Windows-based server, we have a wide array of choices for clients. As we said earlier, any client, anywhere. If it runs Windows, iOS, Android, Linux, it can connect to our remote desktop server and run applications. Our users can use existing PCs, a tablet, a MacBook, a purpose-built thin client, or a PC stick, and even a phone. Let's look at the purpose-built thin clients first. This PC stick costs $155, or all in $511 per user when we add in the server and hardware licensing costs. Compared to our $900 PC, that's $389 in savings per user. This PC stick will drive a single monitor. Just plug it into the HDMI port, attach a keyboard and mouse, configure the Wi-Fi to connect to the remote desktop server, and you're off. Well, if you need more than one monitor, this Dell Wyse Thin Client goes for $478. As you can see, it's tiny. It can mount on the back of a monitor. This thin client supports dual monitors and it's still going to save you $66 per user. You can also get thin client laptops. When you add in the $356 per user cost here, you get about the same cost as a fully capable laptop or thick client, but there are additional costs. No additional costs, such as no antivirus needed on a thin client, no labor to install and configure to get ready for use, no ongoing maintenance costs. Plus, since all this device needs to do is connect back to the server where all the heavy lifting takes place, it's pretty much future-proof. We see many thin clients in use 10 years or more. With all the processing happening on our server, our clients can be cheaper or even older devices. We've taken old PCs that have Windows 7 on them, installed a free Linux operating system, and now they'll continue to get security updates and can act as a client to the remote desktop server. And then there are the devices users have already and would like to use for work. An iPad or Samsung tablet or a MacBook can be used to connect and run our Windows-based applications. We work with many clients where the executives love their MacBooks and want to use them at work. A remote desktop server gives them access to the company's applications in the office and remotely. They can leave all their work open on the server session desktop and just disconnect. That leaves everything running. Leave the office when they get home, they can reconnect and continue right where they left off. And finally, we can even use a phone. Paired with a Bluetooth keyboard, and I know what you're thinking, there's no way I can work on that tiny phone screen, right? Well, with the addition of a Miracast wired display adapter, you can have your desktop on a full-size TV screen. Every hotel room is going to have a TV with an HDMI port in it. This can be a great way to travel light and still have access to your business applications. Next, let's review the technology in server-based computing that allows us to access it anywhere. The remote desktop server is connected to your backend servers. These servers are interconnected over high-speed links. We configure servers with a minimum 4 gigabit Ethernet ports, so it's 4 times faster than your standard PC connection. In some cases, the backbone is 10 gigabit Ethernet, which is 10 times faster. Because data is retrieved from a server, performance is better since the servers are always more powerful. As a techie, I love the fact that you can harness all of this power with a cheap bulletproof thin client. But when we look at the connection from the servers to the thin clients, we have a different story. All that has to pass back and forth are screen updates and keyboard and mouse clicks. So this allows us to access our high bandwidth, high powered server-based computing environment over low bandwidth, cheaper internet connections. So when we talk about minimal requirements in bandwidth, here's how powerful that concept gets. You can use a MiFi device or tether your laptop or tablet to your phone to get internet access. Now you can work wherever you have 4G LTE signal. Work on the beach at the Jersey Shore. And while that's possible, it is more likely your road warriors will appreciate not having to hunt down Wi-Fi at a Starbucks, for example, to get connected to do their work. Let's touch on another major benefit of server-based computing, security. Your remote staff must connect back to your server-based computing environment to run their applications. There, they're protected by your firewall and any content filtering it provides. This keeps them safe from any known bad websites. They'll also be protected by antivirus and Microsoft updates that are kept up to date on the server. The data is never worked on locally, so if a device is lost or stolen, no data is ever lost. Threats like computer worms, viruses, malware, ransomware can't jump from the remote client to the servers. As simply put, we're only receiving keyboard and mouse clicks from them. So you may have heard of server-based computing used by large organizations, but let's look at some use cases in the SMB market. To start, consider you have 5 staff members that require remote access. If you bought 5 PCs for them to remote into, that'd cost about $4,500. You now have to find a place to keep these 5 PCs. That's 5 power supplies you have to find power for. If you want these PCs to stay up, if there's a power outage overnight or the weekend, you'll need to purchase UPSs for them. There is no redundancy in these desktops, so if a hard drive or power supply fails, well, someone can't remote in until you get it fixed. That's downtime and loss of productivity. You can spend the same amount of money on a remote desktop server solution, and it's going to have dual power supplies and redundancy in the hard drives and a UPS to protect it from power events, so you're much better off. We have clients that use server-based computing for all their remote locations. Thin clients are used at each remote site, with a spare in the closet in case one goes bad. In remote locations, it can be tough to get someone on site over the weekend or late at night if there's a PC down. And that can't stop business, right? Truck's still got to roll. With the thin clients, anyone can replace their own thin client in a matter of minutes and get connected back to the server. Thin clients also work well in dusty environments since no fan is needed to cool the unit, and in locations subject to high and low temperature swings like the security gatehouse. We helped a medical group roll out their practice management app to over 500 staff members. No single server is going to handle all those connections, and this demonstrates the expandability of server-based computing through the use of a remote desktop server farm. Each backend server can handle 70 clients. Clients connect to a gateway server that manages connections to the farm and routes the client to the least busy server. There are 2 gateways here for fault tolerance. If one gateway goes down, the other can still direct the clients. This medical group is growing through acquisition. As they take over practices, it doesn't matter what hardware is currently in place. They just need a connection to the servers hosting the published app. And that connection doesn't need to be a high-speed connection either. For our third example, we have an accounting client that went the route of server-based computing 2 years ago. 1 year ago, when their local servers needed to be replaced, they took the leap and moved their computing environment to the cloud. We moved them to our subsidiary company, Sapphire Cloud Solutions. Their server now runs on completely redundant hardware with redundant power and internet connections. When COVID-19 stay-at-home orders came, their infrastructure was already in the cloud. The office could be dark for that matter. Everyone set up to work from home without missing a beat. And for our final example, we work with a law firm that takes its responsibility of protecting its clients' personal information very seriously. They also make investments to ensure their staff can work no matter what risks threaten the productivity. Citrix Workspace is a cloud-based front end to your on-premise or co-located remote desktop environment. Since clients connect to the Citrix Workspace service, It allows the firm to have no connections directly to their office, not even a VPN connection. The connection is proxied through the Citrix Workspace Cloud service, which completely isolates the server environment from the client hosts. As we discussed in our secure remote access devices webinar, thick clients like PCs connecting over a VPN can introduce malware and viruses if the firewall isn't configured properly. Plus, with no VPN client, there is less to configure and manage. Citrix Workspace protects the firm as hackers can't try to overwhelm their firewall or internet connection with a denial of service attack. No desktop client is necessary. The connections run over HTML5, so there's no worries about installing any software for the clients. This makes using any device a breeze. Just browse to the login page, sign in, and you're working. Your desktop becomes a tab in the browser. If you've attended our cloud security webinar, you know we highly recommend two-factor authentication, and that support's built in. And finally, should their offices go down for an extended period of time, we spin up their servers at our subsidiary Sapphire Private Cloud, and clients connect in through Citrix Workspace without any reconfiguration. They don't know the difference. So in summary, there are many benefits to server-based computing. If you'd like to learn how it can be applied to your operations, please reach out.
All right, thanks, Stu. With that, we'll open our Q&A session. We do have one question in the queue. So this does sound great, Stu, but are there any drawbacks that we should know of?
Yeah, there's just a couple, but they're not that big. I mean, in order to work, you always need that connection to the server, right? A continuous connection, even if it's just 4G LTE. So there's no working offline on a plane, for example. You'd have to pay for the in-flight Wi-Fi. Also, video chat is not supported. The very nature of the connection to the server is it requires little bandwidth. Video requires a lot of bandwidth and local video processing power, which is not available on most thin clients. And like voice over IP calls, same thing. The connection's not optimized for video or voice, so you need a local device to run the app. And we find, many organizations use thin clients where they need them, and they save money, and they gain all the benefits of server-based computing. And it's the staff that really need to do this video conferencing and VoIP, whether they're executives or salespeople. They're going to have a thick client as well to run that stuff on. But many of our clients also fall back to using their phones to handle the video chat and VoIP connections. So not really drawbacks, just different ways to get those services to the staff.
All right, thanks, Stu. Are there any other questions that we see?
No, I don't.
All right. Well, with that, we will close today's presentation. Thank you again for joining us this afternoon. We look forward to seeing everyone at next Tuesday's webinar. And please reach out. You will get a copy of the recorded presentation tomorrow morning, and let us know if you have any questions.
All right. Thanks, everyone.
Thank you.